In this video, I want to give you an application of solving one-step equations. And the application here is the volume flow rate. And what the volume flow rate says is that if we have a pipe, like the pipe right here, the cross-sectional area at a certain point in the pipe times the velocity at that section of pipe is equivalent to the area of another cross-sectional piece of pipe times the velocity at that cross-sectional area. So what this is saying is, if, say I have, say we're talking about this particular pipe, and this particular pipe, it starts to get smaller, right? The cross-sectional area starts to get smaller. So, with my equation, if the cross-sectional area of the section over here is getting smaller, so the area is getting smaller, we know that it has to be equivalent to A1 times V1. So my velocity is going to get faster. Okay? And this is apparent if you think of a garden hose. And if you just turn on the water and use your garden hose, that's like the equivalent of this cross-sectional area here, A1 times V1, right? If we were to put our thumb over the opening of the hose, that would create a smaller cross-sectional area, and therefore the velocity would go up. And what happens when you put your thumb over the garden hose? Well, the water starts to spray out at a faster speed, at a higher velocity. Okay, so that's what this equation is. It's a really simple and useful equation, and it just involves one step if you're trying to solve for cross-sectional area or volume. So let's do an example. In the diagram to the right, so this diagram, what is the velocity of the fluid at the blue cross-sectional area? Okay. All right. Well, let's pull out our equation. We have A1 times V1 is equivalent to A2 times V2. Okay. In this case, this is going to be the yellowish, and this is going to be the blue. Okay, so I want to find out what the velocity is here in the pipe. Now, this formula is going to tell us the velocity is going to increase as the cross-sectional area decreases, right? This is just a proportion. So I'm pretty sure that the velocity is going to increase. It's going to be greater than 2 meters per second. Let's find out. Okay, I have my area here is, cross-sectional area is 5. Oh, I won't put the units, just 5. And my speed is 2 meters per second. Here, my area, my cross-sectional area is 2. So what is my velocity? Okay, so I'll put x, or we'll solve for V2. We won't even need an x. We'll just solve for V2. Okay, let's do it. So on the left, I'm going to combine like terms. I'm going to get 10 is equal to 2 times V2. And V2 is being multiplied by 2, so I want to isolate V2. I'm going to divide by 2. All right? And I get that the velocity at the second cross-sectional area is equal to 10 divided by 2, or 5. So 5, and then I'll put the unit down, meters per second.